Hi everyone, I am Rosa Calo, BSE Science 3 student, and this is Regional Wind Pattern. The learning objectives are: understand the concept of regional wind patterns, identify the driving forces of the regional wind patterns, and explain how these forces influence the wind direction. The forces governing the wind patterns are pressure gradient force, Coriolis force, and frictional force. Pressure gradient simply differences in pressure over a distance, and it is this differences in pressure that leads to pressure gradient force, which is one of the fundamental driving forces of wind. To really understand how the pressure gradient force works, what you must know is this: air naturally flows from areas of higher pressure to areas of lower pressure. To illustrate this, let us suppose that the point A has a pressure of 1013 millibars and point B has a pressure of 997 millibars. Well, because of the pressure difference, air will naturally flow from point A, area of higher pressure, to point B, the area of lower pressure. Now, the greater the difference in the pressure, the faster the flow of the air will be. In other words, the wind will be higher. In weather maps, we can see the pressure gradient by means of isobars, which are the lines of same pressure. The closer the isobars are to each other, the faster the wind is in the particular area. Coriolis force. This is caused by the rotation of the Earth. The Earth rotates faster around its equator than it does in its pole. This is because points near the equator of the Earth have farther to travel in a day or in a 24-hour period than points closer to the poles. This explains the differences in the rotational speed of the Earth on its equator compared to the poles, and this has an impact on the direction of the wind in the north and south hemisphere. In northern hemisphere, Earth's rotation is counterclockwise as seen from the above of the North Pole. In the southern hemisphere, the rotation is clockwise as seen in the above of the South Pole. The Coriolis effect causes free-moving objects in the northern hemisphere to curve to the right and free-moving objects in the southern hemisphere to curve to the left. The last driving force is friction. Friction only influences the direction of wind when it is close to the Earth's surface, and that is typically defined as less than 700 feet above the surface of the Earth. When the wind is close to the ground, it is affected by friction of objects and topography of the surface. But once we get over 700 feet above the surface of the Earth, friction will no longer have a measurable impact on the direction of the wind. In summary, the wind is controlled by the pressure gradient force, the Coriolis force, and friction. Wind speed is primarily dictated by the pressure gradient force, while all three controllers combine to guide the wind direction.